Hi, my name is Aneta and this is Chemistry at Glance. Our today's topic is bonding, electronegativity and bond polarity. If you're not familiar with this topic, as always, I leave all links in the description box below so you can just click on the link. It will take you straight to my blog where I explain this topic. So let's get on with it. Draw a dot and cross diagram for the formation of calcium oxide, showing how it is formed from calcium and oxygen atoms. Only outer electrons should be drawn. So what you gotta do is find calcium and oxygen on the periodic table and see what is their atomic mass, what's the number of electrons on them. Or because we're only drawing the outer electrons, you basically have to look what group calcium is in and what group oxygen is in. We know that calcium is in group 2, which means it has 2 outer electrons. And oxygen is in group 6, so it has 6 outer electrons. Because calcium is a metal and oxygen is a non-metal, we have an ionic bonding going on. Ionic bonding means, let me draw these first. That calcium wants to be stable and oxygen wants to be stable. So calcium wants to get rid of these 2 electrons, but oxygen wants to gain these 2 electrons. So calcium donates the electrons to oxygen so that calcium has a full outer shell and becomes 2+ positive because it gave away 2 electrons. And oxygen wants to be stable as well, so it has 6 of their electrons plus the 2 from calcium, and it becomes negative. And this is the dot and cross diagram for ionic bonding. Our next question states, identify which of the following statements about the ionic compound, so we know it's ionic, rubidium fluoride, is correct. So we know it's ionic, we know it's rubidium chloride, so it's metal and non-metal. And now our statements. The compound conducts electricity when dissolved in water. Yeah, this can be true because when it's dissolved in water, we have these positive ions and negative ions and the electrons flowing. Yes, it can conduct electricity. The compound has a low melting point. This is not true. And this is because ionic bonding is strong. Therefore, energy is needed for it to be separated. And before it can be melted, it has to be separated. The ionic bond is too strong. This is not true. The compound has shared electrons between the rubidium and fluoride atoms. This is basically an explanation of a covalent bond, when we share electrons. This is an ionic bond, so we're not sharing them, we're just giving them away. No, this is not true. And the last one, the compound is a gas at room temperature. We said it has a high melting point, which means at room temperature, it definitely won't be a gas. A is true. The compound conducts electricity when dissolved in water. And here's our next question. Water molecules will hydrate the aqueous hydrogen ion to form the oxonium ion, H3O+, hydronium. Draw now the cross diagram and the displayed formula of the oxonium ion. So at the beginning, we have a water molecule. So as I told you before, you've got 1, 2, 3, 4, 5, 6 electrons on oxygen. They form ionic bond with hydrogen because hydrogen only has 1 electron. So it wants to be full outer shell, because hydrogen's first outer shell has 2 electrons, so it's full. That one is full. That one has 8. Everyone is happy. And now we want to find to create oxonium ion, which is H3O+. 3. We only have 2, so we add another H with a plus, because hydrogen only has 1 electron, and now it's a positive, so it doesn't have any electrons. Therefore, we have our oxygen, and the 2 hydrogens, we have water. Now we added that 1 hydrogen, which has no electrons. Therefore, both of the electrons come from oxygen. This means that this is a dative bond or coordinate bond, where both electrons come from 1 atom. And the next question, how can an orbital hold 2 electrons with negative charges that repel each other? So this is hard to understand. We've got 2 electrons, they're both negative, so they repel each other. So how is it possible that an orbital can hold 2 electrons? And this is because both electrons spin in different opposite is a better word, opposite directions. So one spins in one direction, the other one spins in the other direction. That's why they're not repelling. And the next question, generally what type of boiling and melting points do covalent compounds have? High, medium or low? So covalent bonds are strong. Therefore, they usually have high melting points. These questions are very short, so these type of questions will be at the beginning of your exam, which is just 1 markers. So what is meant by electronegativity? What atom is the most electronegative? So electronegativity, if you haven't read my post, go down and read it. But electronegativity is the ability of an atom to attract electrons. So as you know, the group 1 electrons, they want to get rid of that electron so that they're stable, because it's easier for them to get rid of that 1 electron than attracting another 8. So it's the least electronegative. The most electronegative element is actually fluorine. And let me tell you why. This is because it has 7 electrons. So it wants to attract that 1 electron really badly. And electronegativity is the ability of an atom to attract the electron. So it has a positive nucleus. A group 6, like oxygen, will not be as electronegative as fluorine, because it has less protons in the middle, so less positive charge. So fluorine has the most electronegative because it has the most amount of protons and wants to attract the electron the most. You could say, well, but underneath fluorine we have another element. Yes, but fluorine's outer shell is the closest to the nucleus. This is why it's going to be the most electronegative. Next question is, what is the most ionic bond? So the most ionic bond will be between a metal and a non-metal that has the biggest electronegativity difference. So if we know the most electronegative element is fluorine, we have to find the least electronegative atom. And this is sodium. You could say, well, but hydrogen is the least electronegative. However, hydrogen with fluorine create a hydrogen bond. They won't be ionic because hydrogen bonds is between hydrogen and one of oxygen, fluorine, or nitrogen. So this would be a hydrogen bond. So the most ionic will be between fluorine and sodium. Sodium is the least electronegative because it only has one electron to give away. And it doesn't want to attract. So electronegativity is the ability to attract. And sodium doesn't have any ability to attract. It just wants to get rid of that electron it has. So the next question says, state what is meant by coordinate bond, dative bond. So as I told you before, with a water molecule, coordinate bond is basically a covalent bond because the electrons are shared, but both electrons come from the same atom. This is basically your definition. And you want to remember this definition because they ask about it a lot and it's an easy mark to get. So next question says, explain why each carbon to oxygen bond is a carbon dioxide in a carbon dioxide molecule is polar. The atoms are polar when one of the atoms has bigger control over the electrons than the other. So in carbon dioxide, there is an unequal share of electrons, and oxygen atoms have bigger control over the electrons. This can be figured out by calculating the electronegativity. So the electronegativity value between these and this is so big that the covalent bonds becomes polar. And this is an example of what I told you before. So each element has its own electronegativity value, and we had carbon dioxide. So the oxygen electronegativity value is 3.5, and that of carbon was probably much smaller. This means the electronegativity value was high. So our electronegativity values range between 0 to 2.1. So it starts with covalent, then it's polar covalent, strongly polar covalent, and everything above 2.1 is ionic. So we use these electronegativity values, take them away from each other, and then see where they lay in this range. This is the Linus-Pauling values, the scale of Linus-Pauling. So let's read the question. The electronegativity values of some elements are given below. Use this data to identify any dipoles present in the following bonds. Mark their polarity clearly. So the dipoles, so is that, which means one of the atoms is slightly plus and the other atom is slightly minus. So one has a higher power over these electrons than the other. So we have N and H first. So N and H. So the biggest N minus 2.1, the smaller H, and this gives us 0.9. 0.9 is quite high compared to this. This means it's not just polar, because 0.4 to 0.9 is just covalent. And then everything above is a polar. So it's 0.9. So it's going to be slightly polar. And because the electronegativity of nitrogen is bigger, that's why it's going to have that power over hydrogen. Now we've got OCl. CO is 3.5, Cl is 3, bigger minus is smaller, so we got 0.5. Oxygen will be slightly minus, slightly plus. You don't actually have to even do these equations. what you just gotta do is find nitrogen, hydrogen. Nitrogen has a higher electronegativity value than hydrogen, which means it's gonna be that one who has more control of the electrons. And in this one, oxygen has a higher electronegativity value than chlorine, so oxygen is going to be the one that has more control over the electrons. So oxygen is going to be with minus and chlorine is going to be with the plus. And now we've got use the data to explain why aluminium oxide is an ionic compound while aluminium chloride is considered to be a covalent compound. So we've got aluminium chloride and we've got aluminium oxide. So in aluminium chloride, we do 3.0 minus 1.6, which gives you 1.4. In aluminium oxide, we've got 3.5 minus 1.6, which gives you 1.9. We can see that this one is actually more polar than this one. So according to our Linus Pauling scale. So in this one, the electrons are shared more equally. Which also means this one is more covalent. And as you can see from 2.1, the compound will be ionic and it's 1.9, so it's very close. So this one's going to be more ionic and this one is going to be more covalent. This is our last question. Chlorine fluoride has the following formula, ClF. Indicate the polarity in the bond shown by use of the symbols delta plus, delta minus, given a reason for your answer. So, as we told before, fluorine is the most electronegative. So it will definitely be more electronegative than fluorine. So it's going to attract these electrons more. This means it's going to be slightly more negative because the electrons will be attracted more to fluorine than they are to chlorine. And part B, draw a dot and cross diagram to illustrate the bonding between the two atoms in chlorine fluoride. Include all outer shell electrons. So chlorine fluoride. So you want to draw chlorine first. We know chlorine has 7 electrons. We also know fluorine has also 7 electrons. So what they want to do, they're not going to give 1 electron to one another. They're both non-metals, which means they're going to have covalent bond. However, fluorine will donate 1 to chlorine and chlorine will donate 1 to fluorine. So they're not actually going to donate them, but they're just going to share them. So that both fluorine and chlorine are happy. They're both going to be stable. They're both going to have 8 electrons in the outer shell, which means they're both going to be happy. So they're sharing that 1 electrons between each other. And this is how you draw this. So you draw both atoms, and in the middle they're going to have 1 electron from fluorine, 1 electron from chlorine. 2, 4, 6, 8, 2, 4, 6, 8. Both are happy, both are stable. This was all for this topic. If you're still not sure about this topic, visit my blog. I always give a lot of examples so that you know every single scenario how to do the question. So remember, everything I show you are my techniques and ways of learning and revising. So basically everything I show you are the ways I learned for my exams. If you have any questions about my videos, please comment or email me. I leave all the links in the description box below as always. Also, if you have any comments about the quality or content of my videos, please also leave them under this video. And for now, like, subscribe, and see you soon. Bye!